Let's do section 9.4, page 471, exercise 25, which reads, state why the integral is improper, and B, evaluate the integral or state that it diverges. For exercise 25, we have the integral from 0 to 2 of dx over 1 minus x squared. Now, just by looking at this, we know we're going to have a problem at x equals 1, because that is going to make the denominator equal to 0, and 1 over 0 is going to go to infinity. So this integral is improper because it has an infinite discontinuity at the interior point, which means it's not at the end points, it's not at the limits of integration, it's somewhere in the middle, at x equals 1. Now the book tells us that what we need to do is to break the original integral into the sum of two integrals, and we break them at that discontinuity point of x equals 1. So this is going to become the integral from 0 to 1 of dx over 1 minus x squared, plus the integral from 1 to 2 of dx over 1 minus x squared. And we know that we're not allowed to keep something in our limits of integration that's going to cause our integral to be improper. So we're going to have to turn our integrals into limits. So I'm going to have the limit as c goes to 1 from the negative side of the integral of 0 to c of dx over 1 minus x squared, plus the limit as c goes to 1 from the positive side of the integral from c to 2 of dx over 1 minus x squared. And now we can start looking at how we're going to evaluate our integrals. And I think we're going to have to use partial fraction decomposition. So I want to start by factoring the denominator, and I'm going to get 1 minus x times 1 plus x. And of course, I'm going to break that into two fractions. So I'm going to have a over 1 minus x plus b over 1 plus x. And then I want to get a common denominator again of 1 minus x times 1 plus x. And that's going to give me a times 1 plus x plus b times 1 minus x. And I'm still going to have 1 over 1 minus x times 1 plus x. And because the denominators are equal, the numerators have to be equal as well. So I'm going to have 1 is equal to a times 1 plus x plus b times 1 minus x. What we usually do here is choose our values for x cleverly so that we can determine what a and b are easily. So I'm going to start by letting x be equal to 1, and then I'm going to have 1 is going to be a times 2 plus b times 0, which is going to give me a is equal to a half. And then I'm going to let x be equal to negative 1, which is going to give me 1 is equal to a times 0 plus b times 2. And so b will be a half as well. Now I'm ready to start evaluating my integrals, but I think for this problem what I'd like to do is just evaluate the integral of dx over 1 minus x squared and get it to the point where I want to substitute in my limits of integration, and then I can go back to my specific integrals and their limits up here. So this is going to be the integral of 1/2 over 1 minus x plus 1/2 over 1 plus x all times dx. I'm going to factor out that 1/2, and then I know what the antiderivatives are going to be of 1 over 1 minus x and 1 over 1 plus x. I'm going to have natural logs. However, I'm going to have this negative sign here, and that means I'm going to have a negative sign when I take my antiderivative. So this is going to give me the negative natural log of 1 minus x plus the natural log of 1 plus x. And then I'm going to want to combine these natural logs. So I'm going to have 1/2 times the natural log of 1 plus x divided by 1 minus x. And now I can go back and substitute in up here and worry about what my limits of integration are going to be. So let's go down here. And our big integral, what we're trying to solve from 0 to 2 of dx over 1 minus x squared, which is equal to the limit as c goes to 1 from the negative side of the integral from 0 to c of dx over 1 minus x squared, plus the limit as c goes to 1 from the positive side of the integral from c to 2 of dx over 1 minus x squared. And now what I'm going to have is this overall factor of 1/2 that I'm going to pull out. And then I'm going to have my limit as c goes to 1 from the negative side of the natural log of 1 plus x over 1 minus x. And I'm going to evaluate that from 0 to c plus the limit as c goes to 1 from the positive side of the natural log of 1 plus x over 1 minus x, evaluated now from c to 2. So let's substitute in those limits of integration and see what we're going to get. So I'm going to have 1/2 times the limit as c goes to 1 from the negative side. And I'm going to have the natural log of 1 plus c over 1 minus c minus the natural log of 1 plus the limit as c goes to 1 from the positive side of the natural log of 3 minus the natural log of 1 plus c over 1 minus c. So now we're ready to evaluate the limit and see what happens to c and the whole integral as c approaches 1 from both the positive side and the negative side. So when we look at this, we're going to end up with 2 over 0 as we substitute in 1 for c. And that's going to go to infinity. And the natural log of infinity is going to diverge. And we're going to get the same thing over here. We're going to get 2 over 0, which is going to go to infinity. And the natural log of infinity is going to diverge. So we're going to get that the whole integral that we started with diverges.